All right, we're going to continue our working on completing the squares. We're going to get a little bit more difficult today because we're going to start dealing with completing squares when we have a leading coefficient. The first couple that we're going to do will be normal, what we dealt with last week. Then we'll get into the more difficult ones. Let's go to work. Looking at this page that you have in front of you, we're going to be dealing with the evens as we normally do, starting with the evens. Number 2, I'd like you to go ahead and do number 2. Go ahead and complete the square. I'll give you a quick minute to complete that, and then we'll go over it. All right, let's go through step by step what you should have done. We start by rewriting the problem. N squared plus 10n, and then we leave a space, plus 15 equals 0. In the middle of the space and around the first portion of the problem, we put a parentheses. And then we got to figure out what is it we're going to add and subtract. Well, we do that by taking the middle number, in this case 10, dividing it by 2. 10 divided by 2 is 5, and then we square it. 5 squared is 25. So I know I'm going to add 25 and subtract 25. One inside the parenthesis, one outside. Always the plus on the inside of the parenthesis. Now, inside the parenthesis, I have a perfect square trinomial, which is really easy to factor. It will be n plus 5 quantity squared. Combine my like terms on the outside to get negative 10, and that equals 0. So now, at this point, I have completed the square. And I can see that my vertex will be negative 5, negative 10. That will be my vertex. But I haven't solved this particular problem yet. In order to solve it, I now have to add 10 to both sides and have n plus 5 quantity squared equals 10. Now what? Take the square root of both sides. Now this is one that wasn't pretty like the ones we had last week. Okay? Because when I take the square root of n plus 5 squared, I get n plus 5. And that equals, now 10's not a perfect square, is it? So I'm going to leave it as a square root. I'm just going to leave it like that. All right? Am I allowed? Sure. Now, we could use a calculator to take the square root of it and have some big, long decimal. It's an irrational number. But I don't need to do that. The last thing I got to do to get this n by itself is subtract 5 from both sides. So n equals negative 5 plus or minus the square root of 10. That is the exact answer. That is the exact answer. I like it. If that's not a perfect square, just leave it in square root form. Don't have to take the square root of it or anything. Is that simple? Try number 4, please. And I want you to complete it all the way down to solution. I'll give you a minute. All right, let's look at this one. A squared minus 20a space plus 99 equals 0. Parenthesis around. Negative 20 divided by 2 is negative 10. Squared is 100. So I will add 100 and subtract 100. Factor the perfect square trinomial to get a minus 10 quantity squared. Remember, the sign is right there in the middle. Oops. Let's try that again. Oops. There we go. And then combine like terms on the outside to be minus 1 equals 0. Now that's vertex form. I can see my vertex quickly is going to be 10, negative 1. Oops. That'll be my vertex. Now I want to continue on and solve. Let's continue on and solve. I have to add 1 to both sides. So I now have a minus 10 quantity squared equals 1. Take the square root of both sides. So a minus 10 equals, what's the square root of 1? 1. And that's plus or minus 1. Remember, there's two solutions. It's both positive 1 and a negative 1. So now I have to add 10 to both sides. So A equals 1 plus 10 is 11, and a negative 1 plus 10 is 9. So it crosses at 11 and 9, and my vertex is 10, negative 1. Those are the three most important things that we're looking for. How many people got that? Those of you didn't? Questions? All right, I want to move on into the next step, which is what if we have a leading coefficient? What if we have a leading coefficient? Well, just like any time before, we want to start off with the fact of, do we have a GCF? And if we have a GCF, we want to pull it out. So let's look at number 6. Is there a greatest common factor? Yes, what is it? 6. So I can go ahead and pull out a 6. 6 times r squared plus 2r minus 15 equals 0. Cool? Now, that 6 that I just pulled out is going to sit out there, okay? And I've got to write this stuff that's there. I got to write it down every time, and I'll have to deal with it more at the end, okay? But the first part, it's simple. It's what we've always done. And now I'm just going to keep writing that 6, and I'm only going to concentrate. I'm going to concentrate on this portion right there. Just that, okay? Is that a perfect square trinomial? No, it's not. But can I complete the square? Sure, just like I did before. So I'm going to rewrite the problem. R squared plus 2r space minus 15. Now, this outside parenthesis, I'm going to change that to a bracket just to make it look a little different. Is that okay? Because I also have to put a parenthesis in here, just like I always have. Now, what am I going to add and subtract? Well, 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1 and subtract 1. Everybody doing okay? It's no different. We just have that 6 sitting out there, right? I'm going to go ahead and factor this perfect square trinomial in here, which is r plus 1 quantity squared. I'm going to combine my like terms right there to be minus 16 equals 0. So far, so good? Any problem? The last step is that first set of parentheses that's there. I want to get rid of that. Well, what is it called when we multiply something over a parenthesis? Yeah, distribution. Distribution. So that's what I'm going to do here. I'm going to take this 6 and I'm going to distribute it back. I'm going to multiply it times that, and I'm going to multiply it times that. So when I multiply it times this first one, I'm just going to let it sit there. 6 times r plus 1 quantity squared. You okay with that? I didn't actually do anything. I just moved it inside that bracket. Yes? And then 6 times negative 16 is going to be a negative 96. And that equals 0. What format is this in now? That's right, vertex form. Vertex form. F of x equals a x minus h quantity squared plus k. Here, my a just happens to be 6. Now it's in vertex form. So basically, we added one step, which was pull out a GCF first. Let it sit out there until we get it simplified, and then distribute it back in. Think you can handle that? Let's try one more before I put you out on your own. Okay. Now, number 8, is there a GCF? Not in all. I mean, There's nothing that goes into that 7, right? But there's a GCF right here. Do you see it?
Yeah.
Yes, I do. I can pull out a 4 there. 4 times x squared plus 4x plus 7 equals 0. Cool?
Cool.
Now, that bracket is right there. Do you see it? It's right there because, well, it's right here. That bracket. All right. Can I complete this square on the inside? 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 and subtract 4. All right. Well, this is a perfect square trinomial, so I can factor it. It's 4 bracket, and that would be x plus 2 quantity squared minus 4 plus 7 equals 0. I got to distribute that 4 over that bracket, so I got to multiply it there and there. So where I have 4 times x plus 2 quantity squared minus 16 plus 7 equals 0. Almost done. Combine those two like terms now. To have 4 times x plus 2 quantity squared minus 9 equals 0. Now, this one was a little bit different than the first one, wasn't it? Why? Well, the reason it was different is because when I took out the GCF, I only took it out of these first two terms. That's why that 7 just kind of hung out until the very end. Where in the one before, I was able to take that 6 out of everything. Yes? So reminder, I put a bracket around only what I can take the GCF out of. And then I have to multiply it back in. You okay? Let's try another one. Number 10. Is there a GCF? Only in the first two, right? So I can only pull a GCF out of these two. Now, I could pull out a smaller one and pull out a 2, right? But I want to get rid of this leading coefficient right there, which is why I'm going to pull it out of just those two. What can I pull out? An 8. So I'm left with x squared plus 2x minus 10 equals 0. Now, I need that to be a perfect square trinomial in here, don't I? So what am I going to add and subtract? Well, 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1 and subtract 1. We okay with that? Let me factor this perfect square trinomial in here. Let's bring that 8 down. X plus 2, that all factored is x plus 1 quantity squared minus 1 minus 10 equals 0. Now what? Distribute. Just distribute that 8 back in. It'll go there and there. So I'm left with 8 times x plus 1 quantity squared minus 8 minus 10 equals 0. Combine my like terms now. 8 times x plus 1 quantity squared minus 18 equals 0. Can I get a whoop whoop?
Woo, woo.
Yes? All right. You try number 12 on your own. I'll give you a minute. All right, let's look at it. Number 12. Is there a GCF? Not in the whole thing, but there is a GCF in these first two terms, right? So I can pull out a 5. I'd be left with x squared plus 4x minus 26 equals 0. But I need a perfect square trinomial in the middle. So 4 divided by 2 is 2. 2 squared is. So I will add 4 and subtract 4. We good? This is a perfect square trinomial now in the middle, so I can factor it to be x plus 2 quantity squared minus 4 minus 26 equals 0. Now what? Distribute the 5 back in. So I have 5 times x plus 2 quantity squared minus 20 minus 26 equals 0. So 5 times x plus 2 quantity squared minus 46 equals 0. And now it's in vertex form. How many people got it? It's not enough. Let's try one more. Want me to just do the next one?
No.
All right, let's try it. Good. I'll give you a minute. All right, let's give it a whirl. Nothing comes out of the whole thing, but I can take a 4 out of the first two. So I end up with a squared plus 4a minus 42 equals 0. But I need a perfect square trinomial in the middle. So 4 divided by 2 is 2. 2 squared is 4. So I'm going to go plus 4 minus 4. Okay. Back to the perfect square trinomial. 4 times a plus 2 quantity squared minus 4 minus 42 equals 0. Everybody good with that? Question? No? Now what, Cam?
I don't know.
Okay. See that thing sitting out front?
What out front?
The 4.
Oh yeah.
Does that bother you?
Not really.
It bothers me.
Distributed.
There you go. Distribute it. So I'll multiply it times that stuff inside that bracket. The first one's really simple because I just sit it beside it. A plus 2 quantity squared. And then 4 times the negative 4 is a negative 16. That gets rid of that bracket. That's why this goes away, because I distributed it. So I got rid of that bracket there. So now minus 42 equals 0. So the only thing left is to combine those two like terms. So I have 4 times a plus 2 quantity squared, and a negative 16 and a negative 42 is a negative 58. Now, that puts it in vertex form. We know at that point how to solve it, if we wanted to solve it, or we could graph it, or whatever. Cool? I want to show you one more thing, just for fun. Just straight for giggles. Yep, straight giggles. Okay. This last one, I'm going to write it down here. I got 9x squared minus 18x minus 7 equals 0. We doing all of this work. Why are we doing all this work?
So we know what to do.
So we know what to do. Yeah. What are we looking for? We're looking for 3 pieces of information. 2 solutions and the vertex. That's what we're looking for all the time, right? You guys might be interested in this. Let's look at this particular number 16. Let's go desmos.com. Let's start graphing. That's pretty cool. This last question is 9x squared minus 18x minus 7. Look at that. Look at that. And look at that. I can find out that same information by using Desmos. I just show you that now because that's something that's going to become important to us. But we can use technology to find out the same information. So you could use technology to double check yourself all the time if you wanted to. I'm going to want you to become familiar with that as well as all the processes we've learned recently. Go ahead. Go ahead. It's okay. Woohoo! Yeah. You can be happy. They don't realize just yet what I just showed them. It's okay. I would like you to do the odds for homework. The odds are your homework. Good luck. Have a great day.